Hello everyone and welcome back. In this video we're gonna go over the sound of the Atari 2600, so stick around for that. Alright, so let's get started. I already have my Stella menu open. We're page 2829. We're gonna talk about the audio circuit. So a quick explanation over here. There's two audio circuit, so think of it as two sound channels. You have a left and right, if you will. And like it says over here, independent, they're identical, but they're independent. So think of it, if you're wearing a headset, like I am right now, then or two sound boxes, one left and one right, and both of them can play different different sounds, one from the left, one to the right. But it says right here, they're combined at the end of the day into one speaker. So they're combining because TVs generally has one speaker. So that's how the audio circuit works. And this audio circuit, when working with the audio, we have to keep in mind these three different sets over here. We have a frequency, and a frequency determines the pitch of the sound. So here, let me just draw something really fast. So we have, think of this as, so this is a frequency. So right here you have these two waves going. So then you can go to a higher frequency. So more energy. Higher frequency means there's more energy, so there's more wave on it. So that's pretty much how frequency works. Well, that's pretty much what frequency is. So let me just minimize that. So let's get to the subject. And frequency is assigned to special register, audio F, and have audio F0 left, and audio F1 is right. So that's how it works. And you can have from the values 0 to 31, believing 0 being the highest and 31 being the lowest pitch or frequency that we can have. And it says right here, it produces pulses between 30 hertz to 1 kilohertz. So that's the frequency register, audio F. Next up, you have the noise tone generator. Think of that as a distortion. And you have from the value 0 to 15, but most of them are repetitive. So think of them creating different distortions to your sound. And they also is sometimes referred as the controls. That's why audio C, audio control, and pretty much like frequency 0 and 1. You have the audio control for the left side, so 0, and audio control 1 for the right side. And lastly, you have our volume. This pretty much generates the volume for our game. So go to the value 0 and 15. 0 being completely off and 15 being the loudest. And of course, that's your special register right here, audio volume. And you have volume 0 and volume 1 representing left and right values. So that's how the major works of the circuit is. So let me just jump into the code, into our IDE really fast and work with that. Alright, so we're just gonna go quickly set up some values and store them into our registers and see them work in real time. And then we're gonna jump into the material. I'm gonna jump to another material to cover. So here it is. We're gonna load our values. I'm gonna start into the audio. Let's set A to our volume, and volume 0 and volume 1. Then star X into your audio. Let's do this our control or distortion. 0 and 1. And star Y to your audio. Frequency 0. Oh. Frequency 0. Frequency 1. So that's pretty much it. And let's just as you see, you can have two independent values. So I can load A here and have another value for volumes, but I'm just gonna keep all together. So volume 0 being off, let's start with 2, can be low. Then we have our control. Let's put like I think 8 maybe. So 8. Let's just put 4. And then your frequency, let's put 6, something like that. Low values. So here it is, this annoying sound. So let me stop that. And that's pretty much how it works. You just loading, storing values into it. And let's see, let me put 1 over here. Frequency 1. Actually, frequency 31 means the. Let's just put 30. There it is. A bit lower pitch, if you will. And of course, you can we can change all these values on the fly. You pretty much have to load and store that pretty much every frame or so. So that's, it can change during the frame or something like that. But that's pretty much how it works. I'm gonna jump in right here to our Spiceware audio section, and you're gonna go through that fairly fast. So let's get to that part. Alright, so let's before we get to the main subject or main material, let's go over this manual that we have over here. Our Music and Sound Programming Guide by Paul Slocum. Sorry for if I'm mispronouncing. And here is all the contacting information that you need. But there's a good reference material right here for sound and distortions. That's for our control values for audio control. Here, for example, I know that 0 is silent, but if you want some different control or some different type of distortion, you can use these values over here. So if you set 1 for audio control, you get a saw value. Here's the description, similar to a saw waveform. If you set it to 3, it's going to be an engine sound. Use for engine sound. Here is a square, a bass, default. So 12 is lead and 15 is bus. So like I said before, there's from value 0 to 15. So that's 16 values, but right over here it says a lot of them are repetitive. So there's 8 ones you can mainly work with, and that's a good reference to have right over here. And of course, it's a whole guide about how to make great music. So it's a great read if you want to compose music for the Atari 2600. It's a good material, and I'm gonna put all these links on the description down below. So let's get to the main section, which is our how to add sound effects. And it pretty much right over here we know how to set it up, but Spiceware is a better system how to do it. Oh, excuse me. And let's just go through material. So here is our audio control that I set over here. And like I said, from 0 to 15, had a frequency from 0 highest, 31 lowest. And you have your volume 0 and volume 0 and 1 left and right. And then you can have 0, which is off, minimum, 15 is max, the loudest you can have. So now let's go over his material that he has over here, and it's all saved under this collect zip, which is part of his mini game that he's showing you guys how to create. And here, okay, Alexis didn't say anything. Let's get over here into the main part right over here, and the collect file has 2 files, the collect and the sound effect. So all the collect is doing is just including the sound effects file right into here. So that's what this include SMN file, so just including this into our main file as the collect, because it's common to have a different routine, so he just separated it into a different file. And on the collect, you also have this sound effect left and right, and that's gonna be like your index for your left and right table that you're gonna have over here. Let's go over here, collect left and right, 81 and 82 respectively, and that's, like I said, it's gonna be the index for a table. Let's just continue to this manual, and here there's gonna have three main routines: the update, trigger, and off. Update is gonna call every frame. Trigger is gonna happen when something happens to trigger, so like collide with a player. And off means shut it off. We don't want to keep the value, like the value is gonna stay the same, pretty much like the whole TIA thing. So set it off, turn it off, and have some peace and quiet. So let's go back over here, because like I said, if you don't turn it off, it's just gonna keep playing forever. So that's what happened over here. Another sample. There's nothing turning it off, so that's forever is gonna be. So even if I were to put this over here, the TIA value is gonna stay the same. It's something that we know, that I talked about a lot. So let's go back to the menu, and here it has a table, so you're loading these values from our table. And here you have the frequency, sound frequency. As you notice, this is on table, so this is for the collide sound, collect, pinging, and mover. And here he has the control and volume at the same, simply because where does he put it over here? Because the audio and the volume, the control only require a nibble each, so you can pretty much just have it set in one value and save round space. So here 6F, you save one, you saving round space for our game over here for other stuff. So that's a nice thing, a nice quirk you can use. And right over here is our table. So here's the frequency table, all this, and this is our control and volume table. And if you notice over here, you have sound effects, control, and volume. That's our start point. And they have the collide over here. So this is a collide, this is 2, because it's actually decrementing over time. So all of this, for example, from the collect, I go over here to collect, and it's gonna come here and decrement all the way for every frame till it gets over here. And this times minus sound effects -1 times just says equivalent to dot, which means this line. So this programmer counter line that I'm in, minus this start over here. All of this is handled by the sandbars, -1. So it's gonna set us right over here. This is the same thing over here and over here. That's all that's doing. And here he has our table, how to look better. So this is the collect and this is the collect. So just showing a better way to explain right over here. And here, how is the trigger is happening? So we load Y with a value, and then we jump to the trigger. So trigger. So if you come over here to your sound effects, let's go over here, trigger. It's gonna load X, whatever it's sound effect left. So whatever's on the right over here, left, it's gonna load that. And then it's gonna load our control and volume that's set right over here. So that's the, like I said, it's gonna be the index. And then it's gonna branch. I think there's a branch is not free, so something is happening, just branch over here and so forth. There's a priority over here as well. So all it's doing, we're loading the value. So here it's X, and it's gonna fetch from your control in volume and store that in A. And then at some point on update, Let me go over here. Here's the update, and it's doing the overscan, so it's once every frame. He is going to come over here, so the index value for our frequency is going to get that from X, and then the same thing for our audio, for volume. And then he's doing a left shift over here 4 times, so to move our value, since we save the RAM, but even though we save we save the ROM space, but even though we save the ROM space, we have to, in order to save that, we're gonna have to use some of this 6507 power to do this operation. And then after all of the nibble is set for the control, we start. So left, then right, and same thing. So it's pretty standard one, pretty easy to follow through. Hear what's happening during the trigger, but it's pretty much it. If you go to your sample, that's pretty much what's happening. Just loading and storing, just a better way to do it. And if you want music, it's pretty much it's gonna be kind of equivalent to the same. It's just keep that in mind when you, for example, the sound effects just for this sounds over here. If you want music, it's gonna be quite big. If you remember, like games like Dig Dug, like the that's like what, 5 seconds of sound, and that's pretty big. Even if you want, in all of this, it's pretty much just one left and right combined together. If you want like independent, it's gonna be even bigger. So just keep that in mind if you're making a big music. You're gonna have to have a big ROM size to work with. But like I said, that's pretty much it. And for this video, and in the next one, I'm pretty much gonna go over some tools in order you can use for sounds. There's some tools out there you can use to create music or sounds. So I'm gonna cover the next. And that's gonna be it for this video, and thanks for watching. See you guys.